Next one is IQ mismatch. This property is one of the serious drawbacks of this direct conversion receiver. So we have seen that we are going to use a local oscillator with 90-degree out of phase. So here, if I'm going to give a cos, upper band, I'm going to give sine up. If upper side, I'm going to give cos. Here, I'm going to give sine. Okay. So when you see that when I and Q signals are going to be mismatched, so down conversion will I am going to shift the yellow waveform 90-degree, and shifting will entail severe trade-off. When you do a phase shifting, there will be a lot of noise power gain trade-off involved there. And as we put a simple block 90 degrees, it is going to have a lot of issues on the circuit. Phase shifting is not that easy, and it is going to change the properties of your circuit also. So in some case, if the 90 is not exactly 90, then this one will not be sine and one will not be purely cos, and I and Q channels will not be properly balanced, and there will be imbalances. So this 90 degrees will be always 90. Even if 90 becomes 89 or 90 becomes 95, then your I and Q will be imbalanced, which will lead to what is called as phase mismatch or gain mismatch. You will have either gain error or phase error because of this 90-degree not maintained by the phase shifter. So this is going to be larger problem compared to your the previous thing, because what when you have only one mixer it is okay, but when you have multiple mixers, this change in frequency is going to propagate, and this greater mismatch is whatever mixers are going to be followed by this circuit, they are also going to experience more amount of mismatch. And the gain and phase noise what is introduced inside the circuit, you cannot rectify that. Also, when the device is going to work at very high speed, this mismatch will also increase. So in case of an RF receiver, the maximum tolerable IQ mismatch must be known so that architecture is chosen accordingly. So in the specification of whatever device, whatever architecture you develop, it has to be clearly mentioned what is the maximum possible IQ mismatch error provided by this architect, so that people who are using the circuit will be very, very careful in deciding whether to use the circuit or not. Complex signal waveforms such as OFDM and QAM, this maximum can be obtained by simulation. You can do simulation to see what is the maximum IQ mismatch you get, and how to quantify this two mechanisms. So one is called as bit error rate. So bit error rate is one mechanism where you can quantify this IQ mismatch. Other one is error vector magnitude. So two mathematical parameters are there where you can quantify IQ mismatch. So knowledge about BER and EVM will clearly show how much amount of IQ mismatch is there in your architecture.